The protocol OSPF relies on link state information, link state advertisement. In order to build, a link state database from which the best routes are elected using SPF algorithm, OSPF relies on link state advertisement. See, the link state database is not built manually. The link state database is the source of best route in OSPF. OSPF depends on link state database. When the link state database have got some info, path informations, SPF algorithm can find the best path. But this link state database, how it is built? It is built dynamically by collecting link state advertisement. By collecting link state advertisement, the link state database is built. Yeah. So link state advertisement is the basic building block, basic important block of OSPF. LSAs are advertised by every router on every link. Out of every port, LSA comes. This LSA is collected in LSDB and DBD is shared, summary of LSDB is shared to the neighbors, and neighbors use their SPF algorithm, find their own best path. This we know. This is how OSPF elects the best path. Now we are going to focus on this advertisement types. Yes. We are not just having one type of advertisement, we have multiple type of advertisements. We have LSA types. Our focus is today on LSA types. You see, why are we having multiple type of LSAs? Why there is need for types of LSA? Why are we learning types? Why can't it be one type? Why do we need many types of LSA? Many types, why? Why can't it be just one type? See, OSPF has got many areas. Backbone area, non-backbone area. There is only one backbone area and there are many non-backbone areas. So, we need different type of LSA because you have different areas. The reason why we have different area, so that for each area we can have some isolation from other areas, so that one area will be isolated from another area. Or in another word, if there is any change, if any change happens in one area, that should not impact other area. See, why do we have different newspaper? Take today's newspaper in Karnataka, in Andhra Pradesh, in Tamil Nadu, in Kerala, and compare. Are they going to be same? No. It is today's newspaper, but it is not same. newspaper in Tamil Nadu, newspaper in Kerala, in Andhra, in Telangana, in Karnataka. It is not same. Same date. Today morning only it got released. But it is not same. In Kerala newspaper, you see more information about Kerala and some important information about Tamil Nadu, Telangana, Andhra Pradesh and Karnataka. Why is that? It is because the newspaper readers belong to Kerala. They want to know more about Kerala news, their own local news. Likewise, you have many areas. Each area router needs their own area information more than other areas' info. Because not every time this area member talk to other area. For example, people in Karnataka, they don't go to Annachi Kadai to buy sugar. Annachi Kadai is in Tamil Nadu. So, information about Annachi Kadai in Karnataka is useless. Jayachandran Textiles, Saravana Bhavan. Who wants in Karnataka that advertisement? It's not in Karnataka, so that advertisement is waste in Karnataka. Likewise, a detailed information of one area is not really needed in another area. It's not relevant. So, when one area information is given to another area, it needs to be summarized, it needs to be shrinked, it cannot be that detailed that you have locally. For that you need to have different advertisements saying this is another area advertisement. So you no need to learn all. You can have only the summary of it. See, only when it is of different type you will say this should be detailed, that should be summarized, and this should be shrinked. If there is only one advertisement, then you will not say this. You can't say that. You have different type of LSA. Some LSAs are within one area. They won't go to other area. Some LSAs go to another area. Some LSAs come from external. Some LSA comes because of external network. Like EIGRP, PGP. So, advertisements are not same. We have different types because we got different area. If we have one single area, we have these three problems. What is that? I am receiving too many LSAs. My routing table is too big and I am running out of memory. The OSPF is running too often for me to route. These problems come because when there is no area, there will be too many routers, too many networks, too many LSAs, too big routing table, too much of SPF algorithm running as soon as it receives new LSAs. That's why we don't like to use one big large OSPF network. We break them into multiple areas. And we have multiple areas, then we need to have multiple types of LSA. So far what I have said is, why do we need different type of LSA? Did you understand that point?
Yes.
That's wonderful. Now, when you have multiple areas, we can do summarization on the area border router. If you see this picture here, we have two area border routers. Number one, this one. The other one is this. There are two border routers, this one and this one. This one and this one. These two are area border routers. Why do we call it as area border router? Because it is having one interface on area 0, the other interface on area 1. Here also, one interface on area 0, other one is in area 2. So whenever we got a router membership with multiple areas, and definitely there should be one area 0, we call it as ABR router. Alright, we call it as area border router. ABR router. Now that is the place where we will do summarization. That's the best place to do summarization. For example, if area 1 has got many networks. Area 1 has got many networks, hundreds of networks, which is not relevant for area 2 to know. Like as I said, you have too much of information in Kerala. If you send all those information in the newspaper, Karnataka newspaper, is it relevant? No, it's not relevant. Irrelevant one. We will summarize and send. Yeah. So we will not have send a detailed information of one state to other because they don't take it serious. For them it's not useful. So we do summarization on this border routers. Area border router is the best place to summarize. And we summarize and we send it to area 0. And area 0 will send it to area 2, the summary only. So the advantage is the updates that you send is also minimized. And the router that receives the update will also need less CPU and less memory and less buffer to process and to use in the routing table. So we need the areas. We need this hierarchical routing. Types of OSPF routers. As I said, this is an ABR, area border router. This is another area border router. What about this one? This one is the border between OSPF and the external autonomous system. This may be EIGRP or any other source. So the router that is acting as a border between OSPF and another autonomous system, meaning this router has got membership with this OSPF as well as the other autonomous system. We call such router as ASBR, Autonomous System Border Router. Autonomous System Border Router. And these routers are internal to area 1. These routers are internal to area 0, but they also got special name called backbone routers because they belong to area 0. And this has got another special name called ASBR. So it is not only a backbone router, it is also an ASBR router, Autonomous System Border Router. And we got again another internal router, internal to area 2. Why are we learning all this? Because these are all going to send LSAs and they are not same type, they are different type. ASBR will send different type of LSA. ABR will send different type of LSA. Internal routers will send different type of LSA. You see? Because they all have different role to perform, their advertisements, their LSAs are also different. You got a question?
Yes. Sir,
Hmm.
this ASBR you mentioned, sir, so that one just wanted to confirm the ASBR is the router which is connecting the ABR. Is that so? Area border routers?
See, it need not to be connected to a ABR. ASBR is a router that is a member of this OSPF as well as member of another OSPF or another routing protocol like EIGRP or RIP. That's why it is written there down, you see a cloud saying external autonomous system.
External routers.
So if ASBR is there, what does that mean? There is redistribution. If ASBR is there, what does it mean? Routes from some other source like static route or RIP or EIGRP or another OSPF or ISIS or BGP is translated, it is redistributed into OSPF. That redistribution point is what called as external ASB, Autonomous System Border Router. Autonomous System Border Router, not external.
Okay, then both the routers are the ASBR, right?
Which both router?
The above one.
No. Above one is not connected to external autonomous system. The router whichever is connected, there only we will have two different routes. One from EIGRP, one from OSPF. So now we will do, now we will take the external route and give it to OSPF, and we'll take OSPF and give it to external routing protocol EIGRP. Such distribution is what we called as redistribution. Okay. Virtual link. What is a virtual link? Virtual link is used in two different places. This one, what you see, not many people talk, but this is also there. Whenever you have two discontiguous area, in order to connect them, in order to make them as one, in order to make them one logically, we need a virtual link. You see, area 0 is discontinuous here. It's not, it's supposed to be one area, but it is not in one area. It is, area 0 is in two different group, and in between you have area 1. For some reason, area 1 has come between, or in another where for some reason area 0 is scattered, which is not correct. If for an autonomous system, there should be only one area 0. For one autonomous system, you should have only one area 0. Only then it is called as autonomous system. If you take one country, you cannot have multiple capital. There should be only one capital. Kuala Lumpur is the capital of Malaysia. Do you have any other capital for Malaysia? No. Colombo is the capital of Sri Lanka. Because they are divided into two groups, do we have two capital there? No. If it is one country, then it is only one capital. Likewise, for one autonomous system in OSPF, there should be only one backbone area, area 0. There should be only one. So, virtual links are used to connect discontiguous area to area 0. But the picture is not saying that. Picture is saying area 0 itself is discontiguous. So, first of all, let us learn what is there in the picture. I want to combine these two into one because it is one area 0. So, what do? We put the virtual link in between these two border router so that area 1 will not be visible. There will be a direct virtual connection between these two border area 0 so that they can merge as one area. Do you understand?
Yes.
Here what is happening is area 1 is made as one wire. Area 1 is made to appear like one wire connecting these two routers, so that these two routers will feel that we are having area 0 and it is not area 1. Literally there is area 1 actually, physically. But there is also another connection called virtual link with area 0. So the router will feel that we are not passing through one area called area 1, we are already area 0. So via the virtual link, the routers feel that we are one, we are not divided. So what literally happens here is these two routers are already in area 0 as well as in area 1. These two routers are already in area 0 and area 1. All that we need to do is connect that area 0 part to both. So that area 0 part of this router will have a virtual connection to area 0 part of this router and they get merged. Area 1 part is also there, area 0 part is also there. Using the area 1 reachability, we form area 0 tunnel. Yeah, that is what actually happens. Using area 1's reachability, we form area 1's tunnel. That is virtual link. So virtual link is not only used in this scenario, it is also when an area is not connected back to the backbone area. I'll draw and explain you. Okay, so let us assume you have area 0. This is area 0, and we got another area here, another area here. So this is area 1. This is area 1. This is area number 2. And what we need to do is, we have an ABR and LSS go to other area, no problem. There is no problem for area 0 to send the area 1 updates to area 2 and vice versa. But when you have another area here, area 3, one wire is in area 3, another wire is in area 2. This we cannot call it as area 0. Sorry, this we cannot call it as ABR. No, this is not an ABR. ABR should have one connection to area 0. Do you have any connection to area 0 in this router? No. Do you have it? No connection. One connection is in area 2, another connection is in area 3. This is area 3. Are you following? Are you following?
Yes, sir.
So when there is no connection to area 0, area 3 route cannot go to area 0. But in order to send one area route information to another area, without area 0, it is not possible. Without area 0, area 3 cannot send even to area 2. Assume you have a router here. These networks here will not even go to this router. Will not go. Because what is needed in order to send from one area to another area is area 0. Without area 0, area 1 also cannot send to area 2. Area 2 also cannot send to area 3. Area 3 also cannot send to area 2. Do you understand? Area 0 is must between non-backbone area. Without area 0, one area route cannot go to another area. Area 0 is must. You understand?
What we call as the area 0 is backbone area.
Yeah, it is backbone area. So without backbone, it is not possible to communicate. It's a good point. What do we call that as? We call it as backbone. Without backbone, is there any chance of me lifting my finger or opening my mouth? No chance. My brain is connected only to the backbone. And anything that brain orders will definitely go through backbone to the rest of my body. If I remove backbone, none of the body parts will work. Backbone is important. for any organ. So area 3 is not connected to backbone, not connected to the spinal cord. So area 3 will not be part of this autonomous system. Now, to make area 3 to become one of the area in this autonomous system, what we are going to do is we are going to make this area 2 act as a virtual link. You see, area 2 is having connectivity from here to here. Using that connectivity, we are going to negotiate a tunnel, and this tunnel will be area 0 tunnel. So when you do that, this router will become ABR, because one interface if you have with area 0, then it will become what? ABR. If I have at least one wire to area 0, then it is ABR. So this becomes ABR when this virtual tunnel, virtual link is established. So area 2 will now appear like one wire, will appear like a connection to area 0, direct connection. So if you go to this router and check the neighbor, you will find this router as a neighbor. Are they directly connected? No. Inside you may have 10 routers. Doesn't matter. This router will say I have a neighbor with this guy, because you got virtual link. Virtual link is nothing but tunnel. Do you understand?
Yes.
So we make this router to have a neighborship with area 0, so that this becomes ABR. When it is an ABR, all the area routes will go through the tunnel and then get delivered to area 2 and to area 1. First, all the updates of area 3 will go to area 0 via the tunnel. Even though it is passing through area 2 cannot learn it, because area 3 cannot give directly to area 2. It goes to area 0, and from area 0 it is coming down to area 2 and area 1.
So what do we call this tunnel?
Virtual link.
Normal tunnel. That's
No, it's called virtual link.
virtual link. Yes.
So we are going to create a virtual link between these border routers to combine them. So this is the command. We say area and then area ID. What is this area ID? The area in the middle is what that area ID. For example, in this example here, this area 1 is the area ID. See here, area.
Yes.
We go to this router and we say area 1 virtual link, the IP address of router B. See, we are in router A. We say we want area 1 to become a tunnel. We want area 1 to act as a virtual link. And the virtual link endpoint is where? This router B. See, this is router B's address. And then we go to router B and say area 1 virtual link and router A's address. When you do that, this tunnel will get established. Once the tunnel is established, updates will go like this, and it will go to other areas from area 0. Right? So verification command, show IP OSPF virtual link. Also you can type show IP OSPF neighbor. you will find new neighbor with area 0. See, we have to do this lab and see, virtual link lab. Then only we'll understand better. So let us take like around 8 routers to understand virtual link. 8 routers. This is area 0, so this is area 1. ABR of area 1, area 0, ABR of area 2, this is area 2, this is area between area 2 and 3, and wait, I want to add area 1 internal border backbone, this is area 2, this is area 3. Okay, so we have taken 10 routers. Let me put some circles and make it clear for you. Circle. This is area 2, 3. This is area 2. And this is area 0. And this is area 1. Right, all area must be connected to backbone, but area 3 unable to connect to backbone because it's a new building in Cisco campus, building number 19. So what happened is cabling from new building to building number 4 or 5, where the backbone is a difficult task. It will happen, but it will take time. Immediately, Bangalore Cisco cannot dig the ground, put the fiber. So temporarily, what they did is they took the connection and connected it to building number 18. Building number 18 is area 2. Building number 18 is area 2. So, time being, to manage, we have decided to make area 2 act as a virtual link to connect to area 0. So you no need to now take wire physically to building number 4 from building number 19. For time being, you can manage until they lay the physical wire. Yeah. So this is it. We need to now put the IP addresses and start configuring. Alright, so every router has got a loopback interface with the router name. This is there on every router we are going to put. R means router. If it is router 1, then it is 1.1.1.1.
So we will be configuring the loopback address on all the routers.
Correct. For example, this is router 5, VOS 5.
Fine.
Okay, let me zoom it. You see, the name here is VOS 5.
We can name it as router 5.
Let us just assume it as 5.
Okay, fine. Yes.
Why to name? So that is 5.
So in that 5 router, we'll have a loopback IP called 5.5.5.
Correct. Likewise 6.6.6, 8.8.8.8, likewise it goes. Okay. So I put 8 here and 6 at the last and 7 here. Is the font size okay to you?
Yeah, this is fine.
Okay. This laptop is zooming very nicely. The touchpad is very nice. Okay, so next is let us plan the IP. 10.12.0.0/16. See, I made a mistake. It is not 21, it is 24. Right. So between router 2 and 3 it is 10.23. Between 3 and 4 it is 10.34. 10.45. 58. 87. 76. That's all. So this is the plan. We'll put the IP address, we'll configure OSPF according to the area. Then we will get into virtual link.